Hi friends, here in this video we are going to see a problem on simple stresses and strain. For that, here is the question. Now it is given that two wires capital AB and CD are connected to a rigid horizontal bar BD as shown in figure. The diagram is given. We can see there is a wire AB and then wire CD. Both are connected to a rigid bar BD. Wire AB has cross-sectional area of 100 mm square. The cross-sectional area is given. I'll write this in the form of data. For wire AB, the cross-sectional area is given 100 mm square and capital E, that is the Young's modulus, 130 GPa. So it is 130 into 10 raised to 3 Newton per mm square. Then the length of the wire AB is 1 meter. Its length is given. So it is 1000 mm. Then for wire CD, the cross-sectional area and Young's modulus is given. So it is 200 into 10 raised to 3 Newton per mm square. Then if the load W is 6 kilonewton, as shown in the figure, there is a load kept at a distance 100 mm from B and 200 mm from D. The value of W is 6 kilonewton. So 6 into 10 raised to 3 Newton. Then we have to find out the deflection in both the wires, that is deflection in AB and deflection in CD. So the question is deflection denoted by delta L in AB and delta L CD is what we have to calculate. Now this is the question in front of us. So let us get started with the solution part, and into the solution we need to have the length of both the wires. In the problem they have only given the length of wire AB. Wire CD, its length is not known to us. So when I look into this figure, when I am extending this horizontal line up to CD, we can say that AB is given as 1 meter. So the height up till here where it is in contact with CD portion is 1 meter. This remaining height I have to find out. So I'll give the notation that here we are getting a right angle triangle. This is M. So it is triangle AMC. From this triangle, if I can get the value of CM, then I'll add it into this 1 meter. That would give us the length of CD. So into the solution part. CM is what we have to calculate, and this value of A to M, it is corresponding to the length, which is total length, that is 300 mm here. CM is the opposite of this angle, and here this is adjacent side, so I would be using the formula of tan, that is, since in triangle AMC, tan theta, that is tan of 45 degree, is opposite side, which is CM, upon the adjacent side, which is AM. So therefore CM would be AM tan 45. AM is 300. Therefore CM value would come out to be, it is also 300 mm because tan 45 is 1. Now once I know the value of CM, in that I'll be adding the length of the string AB, and that would give me the total length of CD. L suffix CD, that would be, I can say it is AB or MD, both are same, plus CM 1000 plus 300, so it is 1300 mm. Next, I'll be drawing the FBD of this BD portion, that is the rigid bar. And here, as we can see roughly, that when the load is acting, load would be acting in the downward direction, but these two wires, they are going to oppose the load, so they are offering tensions in the opposite direction. So drawing the FBD, so drawing the FBD here, load is acting in the downward direction, value is 6 kilonewton, so it is 6 into 10 raised to 3 Newton. The distance of the load is given from end B and D. And now the string or the wire is attached at B and D. At B, the string which is attached, that is the wire AB, so it is offering tension in the opposite direction to the load. So this would be tension in wire AB. Similarly, for CD, they are opposing the load, so acting in the upward direction. Now, by looking into this FBD, I can use the condition of equilibrium. So the first condition is summation of Fy is equal to 0. That is the addition of all vertical forces, because we are having vertical forces here. And the convention is whatever the forces which are there in upward direction are positive, and those which are there into the downward direction are treated as negative. So therefore, we have TAB, which is the tension in string AB or the force, plus TCD minus W is equal to 0. So therefore, TAB plus TCD minus W, when it goes onto the right side, it would be plus W, and the value is 6 into 10 raised to 3 Newton. I'll keep this as the first equation. Now I'll use the second condition of equilibrium, that is, I would be taking the moments of all forces about point B. So the next condition of equilibrium is summation of moment of all forces about point B is equal to 0, and the convention is clockwise moments are treated positive and anti-clockwise moments are treated negative. You can also take the opposite of these, and that would give you the same answer. So now I am taking clockwise as positive. So W into 100, that is producing a clockwise moment, plus it is W into 100. Next, TAB is passing through the same point, so there is no perpendicular distance between point B and the tension in AB, so its moment would be 0 because it is passing through the same point. Now TCD, when I take the moment at point B, it is coming into the anti-clockwise direction, so it is minus T suffix CD into the total distance 300, that is equal to 0. So therefore, W is 6 into 10 raised to 3 Newton minus TCD into 300, when it goes on to the other side, that becomes plus. So this answer divided by 300, by keeping TCD on one side, I'll get the value of T suffix CD, and my answer comes out to be, it is 2000 Newton. So I've calculated how much is the force in string CD. Similarly, I'll put this TCD value in equation number 1. So therefore, put T suffix CD in equation 1. So we can get TAB, that would be 6 into 10 raised to 3 minus 2000. So tension in wire AB comes out to be 4 into 10 raised to 3 Newton. Now I would be calculating both the deflection side by side so that we can compare the values. Deflection in AB denoted by delta L suffix AB. It is given by the formula. Basically it is PL upon AE, where P is the amount of load. In AB the amount of load or force is TAB. So the formula would become T suffix AB into length of AB upon area of AB into the Young's modulus of portion AB. TAB is 4 into 10 raised to 3. Length of the string AB was given in the problem. It was 1000 mm. Even the cross sectional area is given, and that was 100. Young's modulus for AB 130 into 10 raised to 3 Newton per mm square. So finally the deflection in AB comes out to be 0.307 mm. That's the first answer. Similarly, I would be calculating for CD, deflection in CD. The force is T suffix CD, which is the tension. TCD is 2000, that is 2 into 10 raised to 3. Length we had calculated 1300. Area is 50. Young's modulus 200 into 10 raised to 3. So from this, the deflection in string CD, it comes out to be 0.26 mm. So these are two unequal deflections in both the wires. That is the second answer. So we have found out the deflections as mentioned in the question. Both the questions have been solved. At the end, if you'll find my videos helpful, y'all can like, share, comment and subscribe our channel and share it among your family and friends. Thanks for watching.